Cracking in asphalt concrete pavements is an inevitable fact. It is something that maintenance managers have had to contend with for years. Neglecting cracks will lead to accelerated cracking and other types of pavement distress. Crack treatment of flexible pavements is a routine maintenance which involves cleaning the crack and sealing it with a crack sealant. The video you are about to see describes and summarizes the proper methods of crack sealing. The video is divided into three main sections. The first section will give you general information about crack sealing. The second and third sections explain the application of cold pour and hot pour sealants respectively.
One of the most cost-effective techniques in pavement maintenance is crack sealing. Cracks occurring on the pavement surface allow water and incompressibles, such as sand, dirt, and other debris, to penetrate into the pavement structure. This penetration drastically accelerates the deterioration process. Sealing the cracks prevents further weakening of the pavement. Crack sealing can extend the life of pavement between 6 months and 4 years, depending on the climate, traffic, type of sealant used, and application method. A distinction should be made in the terminology of crack repair. Generally, the phrase crack sealing refers to routing cracks and placing material in the routed channel. The phrase crack filling generally refers to placing material in an uncut crack. For the purposes of this video, any attempt to place material into any routed or non-routed crack to prevent further penetration of moisture and incompressibles will be referred to as simply crack sealing. The first step in crack sealing is to determine if a crack is suitable for sealing. Cracks that are suitable for sealing include transverse cracks, which run perpendicular to the center line, and longitudinal cracks, which run parallel to the center line. Block cracks are also suitable for sealing as long as there is no evidence of base failure. Evidence of alligator cracking is an indication of pavement fatigue failure, and crack sealing is not appropriate for these areas. Next, cracks are examined to determine the most suitable material for the project, usually either cold pour asphalt emulsion or hot pour asphalt rubber. Cold pour is most appropriate for cracks of 3/16 of an inch or less in width. The main advantage of using emulsions is the fact that they typically do not need heating. Also, they can be applied when the cracks or pavement surface are moist or damp. However, these conditions will extend the cure time significantly. Hot pour seals set quickly, but cannot be placed during humid conditions. The heating process requires the use of additional machinery and imposes higher safety risks. Crack sealing operations should occur when ambient temperatures are between 45 and 65 degrees Fahrenheit. Under these conditions, the cracks are open, which makes it easier to place sealant inside the crack. Traffic control is one of the most important safety issues in any roadwork. Proper traffic control devices should be installed. The Texas Manual of Uniform Traffic Control Devices provides adequate traffic control guidance for Texas Department of Transportation roadwork. During operation, both materials and equipment impose safety concerns on workers and the traveling public. Hence, workers should wear the required apparel, including long-sleeve shirts, leather gloves, and adequate eye protection. All safety precautions regarding material handling and equipment operation should be strictly followed. Crack routing may be performed to provide a uniform rectangular reservoir for placing the sealant. The routing process opens the crack and allows placement of the sealant inside the crack, providing better adherence to the asphalt pavement. It also provides uniform and smooth edges for better and stronger bonding. Crack routing allows the sealant level to be below the pavement surface. This protects the seal from traffic and snowplow contact. The primary tool used in crack routing is the rotary impact router. To ensure safety, All guards and other safety mechanisms on the equipment must be functioning properly. During crack routing, caution must be observed to minimize damage to the surface adjacent to the crack. Routing equipment should follow meandering cracks, missing no more than 5% of the crack's length. Whether the crack has been routed or not, it should be thoroughly cleaned to ensure a clean, dry channel and to optimize adhesion of the sealant to the cracked surface. This is one of the most important procedures in crack treatment, since most recorded failures are due to loss of adhesion. High-pressure air blasting is the most common technique used in crack cleaning. High-power compressors produce a jet stream of air, which is blown into the crack to remove any dust, debris, or loose pavement fragments. This method has proven to be very effective in removing foreign material, but not in drying the crack. Usually, compressed air should have a minimum pressure of 100 pounds per square inch and a blast flow of 150 cubic feet per minute. Airflow should be free of oil and moisture. Blasting operations should always be directed away from passing traffic. Also, the dirt and debris from the crack channel must be blown away from the surrounding pavement area. Cracks should be checked regularly for dirt, dust, asphalt grit, and moisture. For effective, long-lasting crack sealing, proper material preparation and installation is required. Preparation guidelines provided by the manufacturer should be followed for best results. Usually, these guidelines will include placement temperature, heating periods and rates, and moisture conditions suitable for application. When using hot pour materials, be absolutely sure the sealant is not overheated. Overheating can alter the properties of the sealant, which may lead to performance deficiencies.